Remember that a polynomial is a string of terms. Polynomials with 3 terms are called trinomials. Polynomials with 2 terms are called binomials. Polynomials with only 1 term are called monomials. We met them in the last part. This part is about multiplying binomials. So we're going to be multiplying things like 2x plus 1, that's one binomial, by another binomial, such as x minus 3. One binomial times another binomial. That's what this part's all about. Let's multiply the binomials 3x plus 5 and 2x plus 1. All I'm really saying here is I want to multiply this sum by this sum. We already know how to do a problem like just 3x times 2x plus 1. And we also already know how to do a problem like just 5 times 2x plus 1. But I want to multiply both 3x and 5 by 2x plus 1. So all I need to do is add together those products. The 3x times 2x plus 1 gives me 3x times 2x and 3x times 1. The 5 times 2x plus 1 gives me 5 times 2x and 5 times 1. And I want to add those two products together. 3 times 2 is 6. X times x is x squared. Plus 3x times 1 is 3x. 5 times 2x is 10x plus 5 times 1 is 5. And I'm adding those two products together. Now, since I'm adding all of these things together, it doesn't matter what order I add them together in. So I'm going to add together the things that are similar. In other words, I'm going to combine like terms. I get 6x squared plus 3x plus 10x plus 5. This is my final answer. Notice that what I'm doing is taking each of the things in the first sum and multiplying it by everything in the second sum. Once I've done that, I can go back and take the second thing in the first sum and multiply it by everything in the second sum. So this is one way to approach this problem. But here's another. Starting with the first term in the first set of parentheses, distribute across the second set of parentheses. This will give me 3x times 2x plus, that's this plus right here, 3x times 1. Now that I've used this 3x on everything in the second group, I can go back and use the 5 on everything in the second group. In other words, distribute the 5. So to this, I'm going to add 5 times 2x plus 5 times 1. Do you recognize this is what we had the last time? Tidying this up gives me 6x squared plus 3x plus 10x plus 5. And I can combine my middle terms because they're both just x terms. Same thing as I got the last time. This approach is very subtly different from the previous one, but whichever one works for you is fine. In fact, your textbook calls this particular method the FOIL method, and you may have heard that term before. What's happening here is I'm taking the first term and multiplying it by the first term in the other set of parentheses, 3x times 2x. Then I'm multiplying the outside two terms, the 3x and the 1. So plus 3x times 1. Next, I'm multiplying the inside two terms, the 5 times the 2x. So plus 5 times 2x. I've run out of room. Lastly, I'm multiplying the last two terms, the last one in this group times the last one in this group. So plus 5 times 1. And again, this is the same thing as I got here. I'm not crazy about the term FOIL, F-O-I-L. First, the first two terms. Outer, the outside two terms. Inner, the inside two terms. And last, the last two terms. It's fine for a binomial times a binomial, but if you multiply a polynomial times a polynomial where either one of them is bigger than a binomial, FOIL doesn't work because you'll end up leaving things out. I don't object to the practice. I only object to the fact that it's tempting to use it regardless of how big my polynomials are, and it only works with a binomial times a binomial. However you got the answer here, if that's the answer you ended up with, then you're doing it right. Here's the same problem again. I'd like to do it by stacking them this time, or the column method. Your textbook calls it the column method. This is similar to what we did in the last part, except that instead of just having a monomial on this line, I have a binomial. Whenever you multiply two numbers like 35 times 21, the algorithm we learned in school goes like this. 1 times 5 is 5. 1 times 3, this is really 30. 1 times 3 is 3. 2 times 5 is 10, but that's really 20 times 5. So I'd like to write 100. Some people learn to write a placeholder 0 here. Others leave a blank space. Now, 2 times 5 is 10, but this is a hundreds place. So I'd like to carry that instead. Then 2 times 3 is 6, plus 1 is 7. But what I'm really doing here is 20 times 30 plus 100. That's 700. Then I can add my like columns, my ones, my tens, and my hundreds. I can do the same thing with a polynomial times a polynomial. 1 times 5 is 5. 1 times 3x is 3x. Everything was positive, so I'm adding. 2x times 5 is 10x. So instead of writing that here, I'm going to leave a blank space, or I could write a placeholder 0 in the same way I did in this multiplication problem. 2x times 5 is 10x. And 2x times 3x is 6x squared. Now I can add my columns, 5, 13x, and 6x squared. Everything up here was positive, so everything down here is positive. And this is my final answer. Same as I had before. You don't need to know all of these different approaches. You really only need one. Which one depends on you, how you think, how you learn, how your brain operates, how you see math. The one that's right for you is the one that gets you to the right answer with the least amount of confusion.